All right, today we're going to spend some time looking at the normal distribution and how we use that. We've spent a lot of time in class familiarizing ourselves with the table, and hopefully you have a normal distribution table nearby. If you're in my class, your textbook would have it, I believe on page 784, if I'm not mistaken. It's labeled as Table E. Also, you have the pull-out, and I believe there's actually even a copy on your inside cover. So make sure you find that table so that you can do these problems. And we're going to take a look at some examples today of how we can apply concepts that we've learned about the normal distribution to everyday occurrences that we see on a normal basis. First example, Alan's biology class took a statewide test, kind of like the EOC. The mean score on this test was 81, and it had a standard deviation of 5. Scores on this test are distributed normally. So, since we know that this is a normal distribution, we know it's going to be something that's kind of symmetric and bell-shaped with a mean in the middle, and we're going to have to identify how that applies to this problem. So what we know is that the mean of this was 81, mean score. So that means that the middle, we have an 81 in our distribution. Now what we're looking at is we want to identify the percentage. We want to find what percentage of students scored below 70. Okay, in other words, they did not pass the test. So a 70 would be somewhere down here. I don't know exactly where, but we'll just kind of estimate it as that would be about where a 70 is. So what we're looking for is the percentage of students that fell into this area over here. So we have to find the Z for this so that we can apply this on the normal distribution. So the first thing we're going to do is get this to have a mean of 0 and a standard deviation of 1. Well, to start off with, we have a mean of 81 and a standard deviation of 5. So we're going to have to convert that. And the way we do that is to use the Z-score. So we need to make sure we remember the formula for Z-score is Z is equal to X, whatever X we're looking at in the problem, minus mu, which represents our mean, divided by sigma, which is the standard deviation. So we'll apply that to this problem by saying that Z would be equal to the value that we're concerned about is 70 minus the mean, which was 81, divided by the standard deviation, which was not 6 but 5. Sorry. So that works out to be 70 minus 81 divided by 5. That gives us the negative 2.2. And you can put a 0 after that if you like, but that's negative 2.2. And we want to see what comes below that Z-score on the normal distribution. Okay, so we've kind of set this and shifted things so that our mean is now 0, and we have a value of negative 2.2 that we're looking at. So we need to find the percentage that is down here below it, and in order to do that, we're going to go to the normal distribution table. So we'll look up negative 2.2 in the distribution table, and when we find that, we will find a value of 0.0139. Now, the table gives us the value or the area that is to the left. So what that means is that this shaded region over here represents 0.0139 or 1.39% of this data. So we will take that value, since it's less than, we're looking at the area to the left, which is what the table gives us. We'll take that value, 0.0139, and that will be the answer to this question. So if you really wanted to write it as a percent, you just move that decimal over 2 places and you write this as 1.39%, since that's what it asks for. All right, so we know that on this test, 1.39% of the students that take it do not score a 70 or better. They score below 70. All right, part B says what percent of students made an A on the test? Well, an A is a 93 or above, so we need to get above a 93 on our distribution. So again, we'll look the middle of the distribution, is 81, and we're going to try and find where 93 would be. And we want to know how many people score above that, or what percent, so we're going to find this area above 93. So that means we'll have to do this a little different than we did when we found below. So we'll start off by finding the z-score, and the z in this case would be 93, the value in question, minus 81 divided by our standard deviation, which is 5. Now 93 minus 81 divided by 5 is 2.4. That's positive 2.40. So we're going to go to the table and we're going to look up positive 2.40. And when we look that up, we will quickly find the value 0.9918. Well, since this is greater than, we want to get above a 93. In other words, we're looking at the probability that x is greater than 93. We're going to convert or invert that value that we have by subtracting it from 1, and that would give us this. The area that the table gave us was over here on this side, so we know that 0.9918 is the value that's to the left. What we want to find was to the right, so we'll subtract that from 1, and what's left over would be this section out here that we're concerned about. So in this case, that would be 0.0082. So that would be 0.82% of students, not even 1 whole percent of the students that take this exam make an A on it. Okay, that's very low, but again, very low percentage of people failing it as well. So only 0.82% of the students make an A. All right, we continue and we go down to the third part where it says Alan's teacher has said that he would get excused from a project if he scored in the top 15% of the students taking this test. So what we're concerned about is what score does Alan actually have to make in order to get into this top 15%. So let's look at a sketch real quickly. If we have our normal distribution, our mean, again, is here at 81. We need to find the value, we don't know what that is going to give us an area, maybe I should give you a little bit more space there. It's going to give us an area of 0.15 being above it. So we want to know what is going to make this equal 0.15. Well, in order to find that value, we're going to have to use the table. We know that 15% are above it, this score. We need to know what is below here. And of course, that would be 85%. So we know that 85% lies to the left of this score if 15% are above it. And hopefully that makes sense to you. We go to the table because that's where all the percentages are. The percentages are in the table. You always remember that. When in question, percentages are in the table. So we're going to go find the percentage that we want, which is 85% to the left. We want to find that percentage in the table. So we're going to identify the closest decimal, and it probably won't hit exactly on 0.8500, but we're going to find the closest decimal to 0.8500 that we can find. And in this case, that would be positive 1.04. So we know at this point the z is equal to positive 1.04. So what we're going to do at this point now is go to our formula. Remember, z is equal to x minus mu divided by the standard deviation. We will plug in what we know. We know z is 1.04. We do not know x. That's the score we've got to get this 15%. And we know the mean. The mean was 81. And we know the standard deviation was 5. So we're just going to solve this equation for x. So we'll start off by multiplying 5 to both sides. And that would leave us with 5.20 over on this side. And on the right side, we would be left with x minus 81. So our last step would be to add over 81, and we will find that x is equal to 86.2. That means that on this test, Alan is going to have to get an 86.2 or higher to get into that top 15% of students. Well, obviously he can't get an 86.2 because the scores don't come that way. So what he will have to get is he'll have to score an 87 on the test, because that's what's going to get him above that 86.2 mark. He can't go below to 86, even though we might round 86.2 to 86 normally. If we go down to 86, we're going to be below this mark, and we would not be quite getting into that top 15%. Okay, let's take another example and look at that. The Snack Pack Potato Chips Company produces bags of chips that have a weight that is normally distributed with a mean of 3.6 ounces and a standard deviation of 0.2 ounces. So little bags of chips. When you buy a little bag of chips like that, you'll read on the package that if you look at the very bottom in the small print, it'll tell you what the weight of that package is. To be safe, on their bags, they print that the weight is 3.5, even though there is a mean of 3.6, and there's a standard deviation of 0.2. So what percent, the question we're being asked here is what percent of bags actually weigh less than 3.5? So again, we look at our distribution, and the mean, the real mean is 3.6. We're going to look at the value 3.5, and we want to know what percent of the bags of chips are coming in less than 3.5. So this is the area we're trying to find. So we will quickly look up the z-score for 3.5 and use that value from the table. But in order to do that, we first have to find the z-score. So our z, again, is going to be x minus mu divided by the standard deviation. In this case, x is 3.5. We're using mu as the mean, so that would be 3.6, and our standard deviation is 0.2. So when we subtract all this out and divide, we get a z-score of negative 0.5. So we're going to go to the table and we're going to look up negative 0.5. Why are we going to the table? Because the question is asking us for what percent we are going to find, and as we said earlier, percentages are in the table. So we're going to go look at the z-score for negative 0.5, or the z-score of negative 0.5, and find the area to the left of that. And when we look up that, it's going to tell us that to the left of 0.5, or negative 0.5, we have an area of 0.3085. Since what we are looking for is actually less than 3.5, we will use the value from the table, 0.3085, as our answer, meaning the percent that is less than 3.5 ounces is 30.85%. 30.85% of the bags they're producing come below this mark of 3.5 ounces. Part B, what percent of bags weigh between 3.5 and 3.75? Okay, we have a question where it's asking us what comes between two values. So what we have to do is find the z-score of both of those. Real quickly, we'll look at a distribution, and I'll just kind of do a rough sketch. We have 3.6 is in the middle. 3.5 would be to the left of that. And to the right would be 3.75. That would be maybe over here a little bit. And what we're trying to find is this area in between those two values. So to do that, we find the z-score for both values. We'll start off with 3.75. So that would be 3.75 minus 3.6 divided by, 0.2. So that gives us a z-score there of negative 0.2. 0.75. So we'll use that, and we'll have a z-score for the 3.5 as well. We already kind of worked that one out. If you look above, 3.5 minus 3.6 divided by 0.2, that comes out to be negative 0.5. So we're going to look up 0.75 and negative 0.5, and we get values for those. The value that we get when we look up positive 0.75 would be 0.7580. The value that we get when we look up negative 0.5 would be 0.3085. Now, when we look at the value between two values, or the area between two values, we are going to subtract the areas, or the percentages. Okay, so we're going to subtract these two values to get our final answer. 0.7580 minus 0.3085 would give us a final area of 0.4495, or 44.95%. I'll write it up here because I'm running out of space. 44.95% comes between 3.5 and 3.75. Okay, the last part of this question asks us to identify the percent that weighs more than 4 ounces. Okay, so again, we've got our distribution. The mean is at 3.6, and we are going to test out the value of 4.0. And we want to see how many or what percent of the bags that are produced actually weigh more than 4 ounces. So what we'll do again is we'll find the z-score for that. That would be 4.0, and I'm sorry, we're trying to find above because we want more than 4.0. So we're going to find 4 minus 3.6 as our z-score divided by 0.2, and that's going to give us a z-score of exactly 2.0. So we look up that z-score in the table, 2.0, and what that tells us is that the area to the left of 4, or that 2.0 z-score, is 0.9772. Now again, that is the area to the left. We are concerned about the area to the right. So what we must do in order to find that is subtract that 0.9772 from 1. So we will say 1 minus 0.9772, and that gives us a value of 0.0228. So basically 2.28% of the chips, or of the bags of chips, weigh more than 4 ounces. Not very many, but it does happen enough to say that it does happen. It's 2.28% of the time. So real quickly recapping, we had 3 different situations in this problem. The first one, we were looking at the value below something. So we were identifying what was below, so we just took the value straight from the table. We looked up our z-score in the table and got 0.3085. That was our answer there. For part B, we are going between two values, and when we go between two values, we look up those values in the table and we subtract them. For part C, we had to find what weighed more than something, so we wanted the area to the right. And in order to find that, we always subtract from 1. So we look up the value in the table and we say 1 minus whatever that value is. And that pretty much sums up all of working with z-scores in the normal distribution. Let's look at one more example and we'll wrap it up. The operating life of a Sportsmaster fishing reel. So there's this company, Sportsmaster fishing reel, that makes obviously fishing reels, okay? Their operating life is normally distributed with a mean of 48 months and a standard deviation of 6 months. So this fishing reel lasts 48 months on average and has a standard deviation of 6 months. The manufacturer is guaranteeing this product for 43 months, and they will replace any reel that breaks before then. So basically, if you buy this fishing reel and it breaks before 43 months or 43 months or less, they will replace the fishing reel. So the question is, what percent, and remember we get percents from the table, what percent of the reels should they expect to replace? So they're going to have to replace some if they have that guarantee. What percent would they have to replace? Well, let's look at the percent that's going to break down at 43 months or less. So we have a mean of 48 months, and we are going to look for where 43 months lies on this scale, and we want to know the percent that is going to last 43 months or less. Okay? We want to find what comes less than that 43. So we want to know the percent that falls over here to the left of that. Okay, so again, you should kind of be preparing your mind for what we're going to do. We will find the z-score for 43. So we'll say 43 minus 48 divided by our standard deviation, which was 6 months. So we'll divide that by 6. So 43 minus 48 is negative 5 divided by 6. And that gives us negative 0.83 repeating, which will round off to negative 0.83. So we have a z-score of negative 0.83. The mean will shift to 0, and we'll say that we're negative 0.83 standard deviations below the mean. So we go to our table, we look up negative 0.83, and real quickly we will see that we get a value of 0.2033. Okay, so what percent are they going to replace? They will replace 20.33% of the fishing reels that they produce. That might not be a good thing if you're that company. That might be too much. But we know that if that breaks down in that time period, it's going to get replaced, so that 20.33% of the fishing reels that are made are going to break down in that time period. Well, the CEO is not happy. This is part B. The CEO is not happy because they're replacing too many reels. It's costing them too much money to replace all of them. So she has decided to shorten the guarantee period to fix that issue. So what she wants to do before she gets started is she goes in and she says she wants to replace less than 8% of the reels that they make. So how short should they make the guarantee period if that's the strategy she wants to employ? Well, again, we know the mean is 48 and we know the standard deviation is 6. So we're just going to apply that information. We know that we're going to be looking at our distribution, and we don't know what time period it is, but we know whatever time period this is, we want the area back here to be equal to 0.08. Okay, so we're going to go to our table, which is where the percentages are. Since we have 8%, we're going to look up 8% on the table and find the closest z-score that we can find to that. Okay, when you go to that table, you will find the closest you can get to 8% is 0.07, or excuse me, 0.0793. So we will find that in the table, and that is a z-score of negative 1.41. So we are going to use that z, negative 1.41, to find this percentage and get it down to be 8%. So we're going to set up the equation. Negative 1.41 is equal to, and again, we're using this formula right here. We know our mean, we know our standard deviation, and we know z. So we're going to plug in what we know. We don't know x. We know the mean is 48. We know the standard deviation is 6. So we will quickly multiply 6 times negative 1.41. In other words, we'll multiply 6 to both sides. Solve this equation. And that gives us negative 8.46, I believe, when you multiply that out. and that's equal to x minus 48. And then we add 48 over, and we find that x is equal to 39.54 months. So they're probably not going to come out with a guarantee that says 39.54 months. They would either round that up to 40, or if they wanted to make sure that they got less than 88%, they would go to 39 months as the guarantee period. If they went up to 40, that would be fine, but it would still get them a little bit more than 8% of the reels that they were making breaking. So it's a good example about how we go to the table with the percent and work backwards to find the X value or the raw score, what have you, that we're dealing with in the problem. Okay, again, remember that the percentages come from the table. So if we're asked to find the percentage, like we were in part A, we just go to the table and get that percent after we find the z-score. If we have the percent and we need to find the x or the z and the x that go with it, we're going to take that percent to the table and locate where it is. And with that in mind, that'll kind of keep you in mind with which direction you should be going with these problems. Hopefully you've got it, and you've been given a packet in your class to work with, so plenty more examples to do. Take some time, go through the review that you've been given, and we'll have a quiz coming up on this shortly. Please be prepared for it. If you have any questions, talk to me in class. I'll see you then.